We want to determine the following limits using the graph of f of x provided here in red. We first have the limit as x approaches 3 from the right, or from the positive side, of f of x minus 3 divided by f of the quantity x plus 3. To determine this limit, we'll consider what's happening to the numerator and denominator separately. So beginning with the numerator, let's see what's happening to f of x minus 3 as x approaches 3 from the right. Looking at the graph, here's where x equals 3. And if we approach 3 from the right, or from the positive side, we're approaching from this direction here. Notice how the y value or function value is approaching positive 2. And therefore the numerator would be positive 2, and then we have minus 3 divided by, now looking at the denominator, notice as x approaches 3 from the right, the input into the function would be approaching 3 plus 3, or 6, from the right. So going back over to the graph, here's where x equals 6. Again, approaching 6 from the right, or from the positive side, we're approaching from this direction here. And notice how the function value, or y value, is now approaching positive 4. Now simplifying, we have 2 minus 3, that's negative 1 over 4, and therefore the limit is equal to negative 1/4. Let's take a look at our next example. We have the limit as x approaches 7 from the left to the negative side of f of the quantity f of x minus 2. We'll begin by determining what's happening to the inner function f of x minus 2 as x approaches 7 from the left. Well, here's where x equals 7. So if we approach 7 from the left to the negative side, we're approaching from this direction here. And notice how the function values are approaching positive 6, but they are approaching from values that are less than 6. So as x approaches 7 from the left, f of x is approaching 6 from the negative side, or left side. But then notice how we're subtracting 2. And since 6 minus 2 is equal to 4, the quantity f of x minus 2 is approaching 4 from the left, or from values that are less than 4, as x approaches 7 from the left. So now we want to determine what's happening to the outer function f as the input is approaching 4 from the left, or from the negative side. So going back to the graph, notice here's where x equals 4. But if we approach 4 from the left to the negative side, again we're approaching from this direction here. And notice how the function values are approaching positive 1, and therefore our limit is equal to 1. Now let's take a look at our last example. We have the limit as h approaches 0 of f of the quantity 6 plus h minus f of 6 divided by h. Well, notice as h approaches 0, the denominator would be approaching 0, and the numerator is also approaching 0, because as h approaches 0, this would be approaching f of 6 minus f of 6. So to better understand what's happening here, let's take a look at a diagram of a secant line. The slope of a secant line, or line passing through 2 points, where the points are x comma f of x and x plus h comma f of x plus h, would be given by this quotient here. We can think of this as y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1, or the difference of the y coordinates divided by the difference of the x coordinates. Notice in the denominator, the x's would simplify out, leaving us with just h. If we take a look at this graph for a moment, if the red graph was the function, we were trying to find the slope of the secant line passing through these 2 blue points. Notice how the blue line would be our secant line. This formula here would give us the slope of the secant line. But notice how the horizontal distance between these 2 points, using this notation, would be h. So as h approaches 0, this blue point here would be approaching the other point we're using to find the slope of the secant line. So as h approaches 0, the secant line is actually approaching this green tangent line. Therefore, if we take the limit as h approaches 0 of this quotient, often called the difference quotient, it actually represents the slope of the tangent line at the point x comma f of x. So going back to our last example, the limit as h approaches 0 of this quotient would be the slope of the tangent line at x equals 6. So going back over to our graph for a moment, notice here's the point on the function when x equals 6. And luckily we have a segment here that we can find the slope of, because the slope of this segment would be the same as the slope of the tangent line at this point. So for example, if we use this point and this point here to determine the slope of this segment, notice how we have to go up 2 units and right 1 unit, and therefore the slope would be positive 2 over positive 1, or just positive 2. Therefore, this last limit is equal to positive 2, the slope of the tangent line at x equals 6. I hope you found this helpful.